All right, you're welcome to this comprehensive data science course. We want to unleash the concepts and practical applications of data science programs. And we want to start with introduction, which is a foundational knowledge of data science. This is just a general overview of concepts and followed by the applications or hands-on tutorial. So we are going to be looking at both theoretical and practical applications of the data science programs here. So we're going to start by just introducing you to the data science environment. Then we go further and continue with practical application. So you are welcome to this data science program. Now, what is data science? By the way, my name is Olalekon, and I want to start by defining what data science is. Data science is the study of data and how to derive insights from structured and unstructured data using various approaches, algorithms, systems, and tools. Nowadays, data science has gone beyond what it used to be before. Now we have several approaches, we have several algorithms, we have many systems and tools that are used in data science. Data science is now is a multidisciplinary field which has emerged as a critical skill set in today's digital age with applications across industries and sectors, making it relevant and beneficial for a wide range of individuals, from students and professionals to researchers to entrepreneurs to policymakers and beyond, enabling them to extract actionable insights from vast amount of data. All right. So this is to equip them with non-necessary knowledge and tools that are required. So data science is a very broad area of field, of area of study, and it has very several components. Okay, it has several components such as domain expert, mathematics, computer science, and you need computer science because a science of computer is needed for you to achieve your goals in data science. We also need mathematical knowledge to achieve it. Oh, you don't need to be a mathematician, but you need the knowledge of mathematics. You don't need to be an expert in every area, but at least have knowledge in the domain area that you want to explore. For example, if you are want to explore business area in data science, you may not be a business person, but you need the knowledge of expertise in that area. You need to bring in somebody who have knowledge or go and do a thorough study in that area. If not, you will not be able to deliver. So it requires a data processing, it requires statistical research, analysis, it requires machine learning. Machine learning is a component in data science. Data science is broad. Machine learning is one of the components, okay, in data science, and because it encompasses all those areas, it picks from here, picks from here, picks from here, picks from here, and bring them together. So it makes a broad area of field where of study. So it connects to many parts of the general field. So we have domain experts. Like I said before, you may want to study area in bioinformatics, for example. You may not be a guru in that area. You need somebody who is expertise in that area. You bring the person in and let the person help. So we need many collaborative work in area of data science, and the key processes is that it have what's called data collection. All right, data collection is very important in data science because when data is collected, it begins with collecting relevant data from various sources. Data must be collected. I mean, not in data, but the relevant ones. We have a pre-processing. Data scientists clean and pre-process the data to make it suitable for analysis. This is very important. It's called data wrangling. Data must be pre-processed for it to be used, for it to be suitable for data analysis. We have EDA, it means exploratory data analysis. It's exploring and visualizing the data to understand its characteristics and patterns and identify relationships between variables. All right, we also have statistical analysis. We have several types of analysis actually, but these are methods applied to quantify relationships and patterns observed in the data. And we have machine learning, building predictive models, and making automated decisions based on the data we have acquired. And we also have visualization. Visualizations such as plots and charts help stakeholders understand complex data patterns and trends. This may not be able to be understood. Presenting the code or behind the scene to the stakeholders may not be necessary, but by presenting charts, it speaks volumes of information. All right, we have applications area. We have business for customer segmentation, market analysis, demand forecasting, and optimization of business processes. We have area in finance for fraud detection, risk assessment, algorithmic trading, and customer relationship management. We have in healthcare for disease prediction, medical imaging analysis, personalized medicine, and improving patient outcomes. We have also in e-commerce for recommendation systems, user behavior analysis, pricing optimization, and supply chain management. This is just a snapshot of the area of application. There are many areas of application of data science, and we will see more as we journey in this course. Why data science or data analysis is so important? The first one is because of accurate data. You know, accurate data is very important. Data analysis ensures business obtain precise information for strategic planning and decision making. All right, we need data analysis that helps businesses acquire relevant and accurate information that they can use to plan business strategies and make informed decisions related to future plans and realign the company's vision and goals. So this is very important, and we also need for better decision making. All right, by identifying patterns and trends, data analysis aids in making informed decisions, leading to improved customers. All right, data analysis it helps in making informed decisions by identifying those patterns and trends in data and providing valuable insights. This enables businesses and organizations to make a data-driven decisions, which can lead to better outcomes and increase success. We have improved efficiency. Analyzing data helps pinpoint inefficiencies and allowing for better resources allocation and increased operational efficiencies. So analyzing data, it helps identify those inefficiencies and areas of improvement in business operation, leading to better resources allocation and increased data efficiency. So we also have a competitive advantage through data analysis. Businesses gain insights, explaining them to innovate, meet customer needs, and outperform competitors. So by analyzing data, business can gain a competitive advantage by identifying new opportunities, developing new products or services, and improving customer satisfaction as well. So we have also risk management. Data analysis, it helps identify and mitigate potential risk, safeguarding the business against adverse impacts. So in this area, we understand that excuse me, analyzing data can help identify potential risks and threats to a business, enabling proactive measures to be taken to mitigate those risks on time. All right. Also, we have a customer insight. Analyzing data provides valuable insight into customers' preferences, enabling businesses to enhance products or services and foster customer satisfaction. All right. So which means that it can provide valuable insight into customer behavior and preferences, enabling business to tailor their products and services to better meet customer needs. So it's very important. All right, so we have a 5 basic areas of data analysis. We have descriptive, we have inferential, we have predictive, we have prescriptive, we have diagnostic. All right, so this area that we have, and then we have to look at each of them one by one. The first one is called the descriptive analysis. It is examine current and past data to identify patterns and trends. All right, so they have different kind of questions individually. They answer individually. All right. For example, the first one, descriptive analysis, answer the question of what happened. All right. So data may be utilized to answer questions and assist decision making in several ways. To choose the optimal method for analyzing your data, one must have knowledge about these five types of data analysis widely used in the area of which might be helpful. Now, this first one, descriptive analytics, is process of looking at both current and past data to find patterns and trends. It's sometimes called the simplest way to look at data because it shows about trends and relationships without going into more detail. Descriptive analytics is a good way to show how things have changed over time. It also uses trends as a starting point for more analysis to help make decisions. So this answer the question, what happened? Some example of this is financial statement analysis, survey report, and so on. So what happened? It's not giving much detail, but what happened? In this category, you can have mode, can have mean, can have median, and the rest of them under descriptive analysis. For example, now, if a patient is rushed to the hospital, maybe the person slumped, okay, or just falls down, and is rushed to the hospital. Doctor will ask, what happened? All right, that is just a very simple question. What happened? It doesn't that doesn't bring about detail. Oh, what if the person falls down or the person slumped? Okay, so that is what happened. Period. So we now go further to what is called inferential analysis. Rather, it involves using a sample to make predictions or draw conclusions about a population. Okay, we have several examples in this area. For example, we have what they call parametric tests and non-parametric tests. But this particular course will majorly focus on parametric tests, all right, towards the end of it. So we have t-test, we have ANOVA, we have a correlation, regression, and the many of that type. So this actually answers the question, how did it happen? Or did it happen by chance? All right, it has to how did it, so something happened in the first part, descriptive, what happened. So now, how did it happen? So this is the question that inferential is asking. So you want to know, did it happen by chance? All right, okay, this person that is brought to the hospital, we know that okay, what happened? It fell down. So how did it happen? It slumped. How did it happen? Is it by chance? Is it by poison? Is it that an accident? Is it how? How did it happen? So this is what a French statistical analyst it look into the what did it happened. Okay, I mean how that thing happened, that event happened. So, but we have what we call diagnostic as well, which investigates why trends and correlation between variable occur. For example, we have diagnostic analytics, which is also the process of using data to figure out why trends and correlation between variables happen, which I just explained now. This is the next step to following identifying trends using descriptive analysis and inferential. One can do diagnostic analysis manually with an algorithm or with statistical software such as R, which we are going to be using in this particular course. This answer question, why did it happen? Don't forget, we have answered the question, what happened? Look at, okay, how did it happen? Now, why did it happen? This is a question that a diagnostic analysis answer. Okay, this person be rushed to the hospital. What happened? It's lumped. Okay, how did it happen? Oh, was it poisoned? Is it by accident? Is it by no? What's the problem? That is what that we explain. Then why did it happen like that? Why did it happen like that? That is what diagnostic analysis is to investigate. Why did it happen? Why did it happen? We have known what happened, okay, we have known how it happened, but why did it happen like that? So this is a question that a diagnosis analysis answer. For example, now maybe a market demand examination, customer before explanation, and the rest of them. It's a good example of why things happen. So we have predictive analysis as well, which use past data to forecast future events and outcomes. All right. So predictive analysis is the process of using data to try to figure out what will happen in the future. It uses data from the past to make predictions about possible future solutions or situations that can help make strategic decisions. All right. Forecasting can help us to build data-driven plans and make more informed decisions. This type of analysis answer the question, what might happen in the future? Okay, we have known, okay, what happened, how did it happen, why did it happen? So what might happen in the future? Okay, can this thing reoccur again? or what is the possibility of this event happening in the future again. Okay, so it answers the question, what might happen in the future. So that is the marketing behavior strategy can be an example, or early disease detection can be an example of this. So, okay, so we also have what they call predictive analysis, which recommends the best course of action based on data analysis. All right. Okay, this particular one is a process of using data to figure out the best thing to do next. All right, this type of analysis look at the important factors and come up with suggestions for what to do next. This makes predictive analysis a prescriptive analysis a useful tool for making decisions based on data. All right, because your judgment is important and needed to give context and limit to what an algorithm comes up with. So this type of question answer the question, what should we do next? All right, we know what happened. Okay, we know how it happened, we know why it happened, we know what might happen in the future. We also want to know what should we do next. This is called predictive analysis. All right, so let's journey. We have data science tools. There are several tools based on language, package, we become based on platform, high performance computing, several tools that I cannot mention. Even nowadays, the trend is going very high. We have Python for languages, we have R, okay, we have packages and tools, we have TensorFlow, we have Keras, and many others, and we have AWS, which means Amazon Web Services, we have Azure, we have Spark, we have Hadoop for big data, and CUDA and the rest of them. So there are several tools that are used nowadays by data scientists, which we can continue to count. They are unlimited now. So we have machine learning data science. What do you mean? We have supervised learning, we have unsupervised learning, and we have reinforcement learning. But in this particular course, focus majorly on supervised and unsupervised learning. All right. Supervised learning means that it has a supervisor in a very layman language. Okay, for any layman to understand, it means it has a supervising agent. All right, that's what it means for supervised learning. It has a supervising agent. It has a supervising agent or a supervisor. So it means that it has a label data. All right, so that is it's simple. We're going to see more about that later, but I'm just trying to give us a snapshot of what it means. And then we have a regression and classification under supervised learning. All right, under that you can see some example of decision tree, linear regression, logistic regression, and so forth. And under supervised learning, we have clustering, we have the dimensionality reduction, right, and several others. So these are just a snapshot of the machine learning in data science. All right, but it's a component of data science. Data science also explore machine learning. All right, so we have data science challenges actually. We have data quality, it's a challenge in data science. That means you have to ensure data accuracy, data completeness, data consistency is fundamental. It's very fundamental in data science. So because data comes from different sources, so because of this, we need to make sure that the data they are quality data. So that is important. And we also have data quantity. You know, especially when you're dealing with big data, dealing with larger volume of data, requires scalable storage, processing, analysis techniques. This is when we bring in what they call Hadoop, Sparks, and even servers to handle those data analysis. In fact, we need machine that are, I mean, a GPU machine that are strong. So it's not just normal like normal CPU machine that we use to analyze normal simple data. So that is their challenge in data science. So we have privacy security issues. We have, I mean, protecting sensitive information while maintaining data accessibility is crucial. Adhering to privacy regulations and implementing robust security measures is challenging, especially in the age of increasing cyber threats. All right, so this is a challenge because many information is being unleashed. All right, because of people are not more secure because of data. You know, anybody can get data from anywhere, and without any necessary policies that is backing it up. We have model evaluation challenge, model selection rather, choosing the appropriate machine learning models, and the evaluation metrics for a given problem is challenging. There are too many models nowadays, too many machine learning models, too many. So to choose the one that is appropriate for your data is a challenge. You need to do a lot of testing, a lot of what they call it now, a lot of performance tuning to get a proper model, machine learning models, all right? So using different kind of evaluation metrics for you to get appropriate one that is best for your data, so for your research. So this is a challenge actually. And we have what they call black interpretability. It's another challenge. Black box machine learning models may lack interpretability, making it difficult to understand the decision-making process. For example, in neural network is a black box operational method. In between many things are happening that it's not open. Okay, so this in this case, to interpret what is happening in the system may not be possible or feasible for people, for researchers or for experts. So we have scalability and performance. Scaling data science pipelines to handle increased data volumes and computational demands can be challenging. This nowadays, because of a scalability issue, performance issue, there are a lot of demands in computation. Computational demand is high. Sometimes mathematically you have to compute a lot of things because data need to be scaled down to minimal level. So this is a challenge, and we have domain knowledge as well. Data scientists may lack domain expertise. Domain expertise making it challenging to understand the intricacies of the business problem. Like I said before when we first started, that under the domain expertise we have a lot of areas of data science, or rather where data science focus on these different kind of fields in business, in science, in engineering, and many other areas. But if you don't have knowledge in those areas, you need to seek for expertise in that area. Collaboration with domain experts is essential to bridge this gap. All right. We also have continuous learning challenge because data science is evolving field, and staying updated with new technologies, algorithms, and best practices is challenging. Continuous learning and adaptation are necessary to remain competitive. You need to continue learning, continue growing, because every day new technology is coming out, new algorithm is being developed, new models is being unleashed. So everything is emerging very fast, very quickly. So the trend is going very high. So you need to be updated. You need to update yourself every day. Keep learning every time. So this is a challenge, okay, for data scientists. All right, we have a career in data science. Okay, we have careers. Data can be a data scientist. If you can also be a machine learning engineer. You can be a data analyst. You can be a data engineer. You can be an AI specialist. You can be a marketing analyst. You can be a NLP, means that language processing. Okay, we have engineer, we have big data expert, we have research scientists, we have business analysis. Okay, so these are the area of expertise that we are talking about. Okay, R programming and RStudio are the major component that we are going to use to run the program. But the R programming is one that we want to install on our computer. The RStudio is a IDE we're going to be using. Integrated development environment. All right, so this is what you're going to be using to run our program. Just go through this particular link and install R first, then install the RStudio. R must be installed first before the RStudio. All right. Okay, so don't install RStudio before R. First install R, then later install RStudio. Okay, download your latest version and install, then we continue. So why R? R is rich in data analysis libraries. It provides tools for data manipulation, exploratory data analysis, visualization, making data analysis task more efficient. All right. It has active community support. It has a large active community support of users and developers who contribute to the development of packages, provide support on forums, and share resources and tutorials. It's very easy to learn and grow very fast using R because there are wide, vast community support for R, and it is open source as well. R is an open source programming language, which means it is freely available for anyone to use, modify, and distribute. So you don't need to pay. Its integration is very perfect. It can easily integrate with other programming languages and tools such as Python, SQL databases, and big data platform like Hadoop, Spark, and the rest of them very easily. And also it promotes reproducibility because such through its support for it promotes its reproducible research through its support for literate programming with tools such as hard markdown, needs, and even now we have Quattro now that which helps in building a manuscript very fast without even writing too much complex code later. And you can even build tutorials, you can build textbooks, even using, you can build research journal and the rest of them using Quarto, because just write once and run later. So you need to write separately. It's like when you're using RMAC now, we are using what they call it now, HTML. So a specialized application, R is well suited for specialized application in fields such as bioinformatics, econometrics, and social sciences, where sophisticated statistical methods and techniques are commonly used. So it has so many specialized areas. So it now depends on each area you want to focus on. So we have the difference between R and RStudio. R is a programming language, okay, which is used for statistical computing, while RStudio is just an IDE, okay, an IDE, integrated development environment. Okay, use our language to develop statistical programs. So you can write a program and run the code independently of any other computer programs. You don't need RStudio to run R, but you need R to run RStudio. Okay, so take note of that. All right, this is a RStudio workspace actually, and we're going to be exploring this later, and we're going to be explaining what I'm going to be what to do in this environment. So just to note, the interface, this will be explained in the next section, in the coding section. So thank you so much for joining us for this particular one. We are going to continue in the practical section later, in our next segment. Thank you so much, and see you in the next segment. Thank you.